Welcome back, everyone online. Thank you so much for sticking with us. Put your kettles on in a few minutes, because before you go to your cup of tea, we've got the most fantastic presenters who you might have just seen their talk. So welcoming Carika Weldon from Bermuda. Most amazing walk-on music. But also, I've never seen the energy of a walk-on music move so fast into such a profound presentation. So amazing job. And Heather Carlson, who's just spoken to us about everything that CDC is doing to think about pathogen surveillance and how we can help people not suffer so much from foodborne infections in particular. And Garrido-Rodríguez, amazing talk yesterday, pitching up to this group of scientists to say, listen to me, and they voted for you, and you gave them a fantastic talk today about organoids. We're going to come back straight to that in a minute. So, Carika, I found your presentation very moving and very disturbing as well. I think we're all aware of all of the health inequalities that we see in the world today, but you really brought it to bear. Can you talk to us a little bit about your personal motivations for seeing the inequality and the way that you're thinking about addressing that in Bermuda, and potentially for other people to learn from the work that you've done?
Yeah, I mean, so I'm from Bermuda, obviously. I have cancer in my family. I've seen it. And then it kind of was amplified for me with the pandemic, because when the vaccine came out, for example, you had most of the white Bermudians that signed up, but the black Bermudians were very hesitant because they knew that medicine wasn't tried on them. So they were like, not too sure. And I really wanted to make a difference with that. And that was seen globally, right? Across the board. So there is a gap, but I'm excited we can fill it. We can fill that gap and actually get the research done and do it locally. So I'm excited for what we can potentially do in the future.
It's absolutely amazing. And Heather, I have to say, when I emailed you and said, would you be interested in coming to be interviewed with me? And you said, well, yes, but we're going to talk about poop. And I said, bring it on. Let's talk about poop. And I have a really serious question for you, which may not sound serious, but it's something that everyone in the world does. We don't talk about it. We don't like to talk about it. But does the fact that we don't like to talk about it affect your science and your funding and the work that you're doing?
Yeah, yes. When I was talking before, about 50 million people in the United States get a foodborne illness each year. But as part of our surveillance, we only get in 65,000 site isolates into that surveillance system. So we go from 48 million to 65,000. And even with that 65,000, we're able to detect up to 400 potential outbreaks each year. So if we had more people that were comfortable with talking about poo and submitting a sample to public health, we could potentially detect even more outbreaks.
What could that look like in the future? Have we got a global network of smart toilets, or how does it look?
That's something that people have been talking about. In my mind, since we all take our cell phones to the bathroom with us anyways, let's be real, everybody takes their cell phone with them to the bathroom. If you just have some type of sampling device that you can hook up to your cell phone, right? You could take your sample, do your sequencing with your accessory for your cell phone, and then transmit that information to a clinician as well as to public health, so we can detect outbreaks so much faster. So people just need to give a poo for science on their cell phone.
This is citizen science.
Yep.
It's citizen science. Well, I think it would be really interesting to drive a public dialogue to see what the appetite for was. Can we get through this barrier of sort of social norms to really help people to suffer less from these conditions? So It's a very interesting conversation. I think we shouldn't be scared to have it.
Yep.
Excellent. So Pedro, how did it feel to be launched onto the big stage, early career scientist, 600 people in the audience listening to your talk? What was that like? Is that the first big talk that you've done, or is it just one of many?
It's the first here in London Calling, and it's really impressive to get up on the stage with all of that people. Yeah, but once you start, it's like everything's flowing. It's just the beginning that's really complicated, I guess. But yeah, it's amazing.
Fantastic. Well, you said to me earlier, I'm a bioinformatician, but you're a bioinformatician who's obviously telling a broader story with the team. So how did you work with your broader team in the lab and in the research group to prepare the presentation?
So I rely on them for anything that touches the lab, because they're the experts, obviously, on that part. And I listen to what they tell me because I'm ignorant. I'm just know about the computers, And you have to learn how to communicate effectively, because are really different domains. And I have to explain to them in a way that they will understand, and they have to explain to me in a way that I will understand. At the beginning, it's kind of difficult, but once you get used to it, it goes smoothly. And it's really enriching, yeah.
Well, there was a very nice moment, if anyone wasn't watching, where we have our STEM students here today, about 60 high school students, and they actually came in on the balcony and they were watching your presentation. And you were talking about organoids and transcriptomes, and this is quite dense scientist for 17-year-olds. And Sarah Agee asked you to explain to the students what an organoid is and why they're interesting. Could you repeat for us that explanation? I think it's genuinely interesting for anyone who isn't in your field of science.
Yeah, so basically, really fast, it's like we want to study the liver, but we don't have liver samples for some reason. So what we do is we create a little liver in a petri dish, if you want to call it like that, and then we can study the physiology and the pathology in the liver. If we want to study certain disease or something, it's easier for us to go to the lab. It's not easy to make the organoids, but it's easier regarding collecting samples and legal implications and ethics and stuff to do it in the lab and then move to the clinic when we're positively sure that something's working.
Fantastic. Well, talking of ethics, Carika, whoa. So I've written this down, and just tell me if I wrote it down correctly. So your study that you presented some results from, 14 months in ethics.
Yep.
6 months in recruitment, 2 months in sequencing, and 6 weeks in analysis. Is that correct?
That's 100% correct.
This feels like it's wrong. What can we do to help the communities to understand the research that you're doing so that we can get more comfortable in doing research which is very well structured? You'd obviously thought about incidental findings. Mm-hmm. You had all the right things in place. Why is it taking so long?
I mean, I think we've kind of broken the ceiling now, so it had to be done for the first time. And one of the feedback from the clinicians was, we want to get this one right because we know you're going to do more. So, it took us a long time for the first one, but we've got prostate cancer, and that took us a lot less. So I think we've kind of broken the barrier now, but it had to be done the first time. It was painful. Very, very painful.
And what was the kind of work, what was the kind of engagement that you were doing? Were you holding meetings to explain genetics?
So we have like a written application that has to go to the ethics board, and then they would come back and they read questions, and we're kind of going back and forth via emails, and we got to the point where we were like, let's have an in-person meeting because, emails were not doing it justice. And then we got everyone on the call, including our genetic counselor, our genomic nurse from the UK, and just let's all hash it out. Because again, it was really clear there was some misunderstandings on certain aspects of things that a simple conversation was able to clear up. And so we got to that point eventually, and then, they had some more concerns, we addressed them, and then there we were, finally with ethics.
You got it. Well, fantastic. Absolutely incredible work. And you were working with GenAX as well on the analysis?
So that was actually funny because I didn't know about them 6 weeks ago. So it was, they were brought in when we had no internet, and we were like, how are we going to meet the deadline for analysis? And then it was like, we have GenAX. I'm like, that sounds like a perfect win. And we met with them, and they were so helpful to help us to get everything set up really quickly so we can get you guys the presentation on time. And, it's just been amazing how everyone's rallied around what we're doing. And I know that there is an inequity in science, but everyone's doing what they can to fix that, which is so encouraging, and we're making progress.
Fantastic. So it's all about just helping people to understand the risks, understand the opportunities, and bring people along on that journey.
Exactly, yeah.
So Heather, in CDC, you obviously spoke a lot about implementation, but where in the work that you're doing at CDC are you starting to sort of break through new barriers where you're trying to help people understand new ways of thinking and maybe break through preconceptions that they might have? What does that look like in CDC?
That's an interesting question. So when I talked about my network for PulseNet, we've been around for 30 years. And for the first 20-ish years of that network, we focused on a technology called pulsed field gel electrophoresis. So switching our network from this PFGE technology, which only gave us 3 bands to detect strain differences, to sequencing, was a breakthrough. You're looking at, instead of 30 bands, 5 million bases for Salmonella E. coli. And it's not just for CDC, it's also for state and local public health labs we work with
taking them on the journey with us or having them lead part of that journey to adopt new technologies. And what I'm really looking forward to is metagenomic sequencing, because, right now we're focused on isolates, but there could be multiple strains that are making a person sick, pathogens that we may rarely see as part of our surveillance network that are emerging to make people sick. And about 25% of foodborne outbreaks, the source is never identified. So I think there's a lot of kind of dark matter for outbreaks there to kind of plumb and understand other potential sources of illness. So I think, we started doing this progression to sequencing, now going into new technologies like Oxford Nanopore for us for our routine sequencing, but thinking about switching again to metagenomics. And, I talk primarily about focusing on the bacterial pathogens here, but there's the whole human side too, and changes in the human genome that may make them more or less susceptible to a foodborne pathogen that could also impact their illness. So there's so many places to go to for this work that I'm really excited and hope we get to explore all of them.
So we're seeing this common theme as sort of fear of an unknown finding in human genetics, fear of an unknown finding, or concern maybe rather than fear of an unknown finding. And I guess then the system being set up to know what to do if you find something that you weren't expecting.
Yep.
And there is a lot of talks happening today and tomorrow around respiratory metagenomics in particular. Really exciting work happening just across the river here in London, where respiratory metagenomics is embedded in ICU that feeds into our public health services, being scaled up to 10 hospitals in the UK. Really great work, but we're seeing all sorts of research in this area.
Yep.
It's great. So I do have a question. I would love you guys to share with Pedro some of your advice as Pedro comes on the start of the journey into a career that either goes into research or into implementation. What advice would you have for someone like Pedro at the beginning of your journey? Or in fact, what advice would you like for the rest of your scientific journey? Have you got any questions for these guys?
There's always this question that comes up when you're near finishing the PhD, which is the typical industry or academia. So I would like to know your point of view on that, because I guess you have different backgrounds somehow, and it could be really good to know both sides of that question.
Yeah. So I went with option 3, right? Industry, academia, or public health. So I went into public health, and why I went into public health and why I really enjoy my job is because I can say I have an impact on human lives. If I detect outbreaks sooner, I prevent illness, I actually save lives. And for how many people in their job can they make that link between the work they're doing, which is, bioinformatics can be kind of dry and separated from where you're having your impacts. But for public health, I can see the impact of my work, and that was really important to me in terms of thinking about what I wanted to do for my career. So think about, at the end of the day, when you go home and try to explain to your family what you do for a living, what's your elevator pitch? What's that short story about why you do your work you do? And that really helped me figure out that I wanted to go into public health.
So interestingly, I've been in all 3. So I initially went into academia. When I finished my PhD, I really wanted to be a lecturer. I wanted to sit on the stage when people were graduating, and so I did that. But I wasn't quite, it wasn't quite scratching that itch that I wanted to be on pioneering research. So I went, still in academia, but doing service, just sequencing service, and then I got sprung into public health with COVID. So I was now in charge of all the testing for Bermuda, and that showed me a different side, but also showed me that if you're not in an innovative environment, that can kind of hold you back as well. So for example, we wanted to do nanopore sequencing, and to a politician, you bought this thing, but you need the other third-party reagent, so we couldn't actually do it. So I got a taste of that, and then I decided to go into the industry, and my real ambition was, I can be in control. I don't have to wait for all the red tape that sometimes exists. It's challenging, running your own company, but it's doing something that I can, again, see that real impact, and knowing that I'm the captain of my own ship. So I think, as
have they said, what do you want to go home at night when you're laying by yourself looking up at the ceiling? Like, what do you want to be doing, right? So I think that's really the question you want to ask, and then go for it.
Yeah, so at the end of the day, the important thing is, go to home and say, what I'm doing makes a difference.
Yeah,
That's amazing.
Yeah.
Thank you.
You're welcome.
Fantastic. Well, that feels like a really good time for me to plug the fact that we're hiring people for Oxford Nanopore. So if you would like to come and join a really purpose-led organisation where we get up in the morning with our North Star being, over the long term, we want to enable the analysis of anything by anyone, anywhere. And for us, that's a business model, but it's also a philosophy in the way we design our products and the way we design our services. And we really think about that. So I think you can do that in public life or in commercial or in academia. As long as you know what your purpose is, it's going to be great fun to get there. Fantastic. Well, that has been a really wonderful discussion. Thank you so much, all three of us, for joining. Thank you. Congratulations on your presentation as well today. Any highlights for the rest of the day that you're hoping to enjoy? Or are you going to get out and have a coffee now that you've done your talks?
Yeah, I need a tea.
Right, well, we have tea, we have food, we have great music in the break, and we have some breakouts. So I really hope you enjoy the rest of your day.